All right, welcome to the next video in our series here on the introduction to code constructs. In this video, where we left off before this was looking at 2's complement and just going through a couple of basic arithmetic examples. In this video here now we're going to start focusing on the actual control structure. So we're going to be looking at if statements, nested if statements, and if statements that have logical conditions. In the video that follows, we'll look at loops and then jump tables or switch statements. Okay, so what is an if statement? Well, it's one of a very commonly used control structures that is used to alter the execution of a program based on conditions. If, and then we have a series of conditions, one or more, and those are tested, and then if it's true, if they're all true, then we enter the if branch, the true branch. If they're not, then we do the else branch. And so that controls or changes the flow of a program. You'll see inside of IDA that they're usually, when we see if statements, relatively easy to identify their use of, as well as loops. When we look at loops, you'll see those are usually pretty easy to identify as well. In order to do an if, though, we have to have a conditional jump. And we have two general types of jumps that we're dealing with, conditional and unconditional. Conditional means that before the jump is taken, there is a comparison that's done, a comparison between values. And so something is compared, and then we have a jump that's based off of the result of that comparison. Not all conditional jumps indicate an if statement, and you'll see that an example of that will be the loops that we'll look at. So just because you see a conditional jump or comparison doesn't always mean that or guarantee that it's an if statement. We'll take a look at some examples. So we'll have two programs. We'll have actually probably two or three that we'll look at today, the source code as well as the resulting program from that. Before we get into that, though, I just want to spend a moment here reviewing the compare. So we have the comparison instruction, CMP, and what that does is it compares two values, two operands, and I'm going to denote those as v-left and v-right, and that's the way that the author in our 314 class does as well. Operand 1, operand 2, v-left, v-right. The comparison, the results of the comparison, is going to take that value from v-left and subtract from it v-right. So compare operand 1 and subtract from it operand 2, or v-right. The result of that subtraction, the result of the comparison, then sets flags, and we have the flags register, or E flags. That's a 32-bit register, and each bit in that register then represents a status. So whether it's set, whether it's a 1 or a 0, then in this case will depend on the comparison, and that instruction will set those flags. Now, we have two different types of comparisons, the comparison between unsigned integers and signed integers. And if you recall, unsigned means that it cannot be negative. It does not have a sign, whereas a signed integer has a sign. It can be negative. And of course, if we have a sign, then we have to have the ability to determine if the results of that comparison gives us a negative value or not. With unsigned, we don't have to worry about that because we're not dealing with negative values. Again, the comparison, the result is the v-left minus the v-right. So these are the possible statuses of the flags. v-left equals v-right. So if you subtract from v-left, v-right, and they are the same value, the 0 flag is set. Right? For example, 2 minus 2 is 0. So the 0 flag is set. And that's what that means. And that can take a little bit of time just to keep straight in your head, that if the values are the same, the result of that subtraction is 0, and that sets the 0 flag. Okay, if it's greater than v-right, the 0 flag is not set, carry flag is not set. If it's less than v-right, then the 0 flag is not set and the carry flag is set. All right, so carry flag being 1, because v-right was larger than v-left, which means that there would have had to have been a carry in order to actually do the subtraction. Very similar with the signed. Okay, we have 0 flag, the overflow flag, plus the addition of the sign flag. And you can go through here, you can see that the results will depend then based off of what happens from that comparison. Now, we generally don't care about precisely what flags are set. What we'll generally care about here is in the next slide, the actual branch instruction that's used. And just like there are certain flags that are set based off of signed and unsigned, there are certain branching instructions that can be used based off of whether something is signed or unsigned. And so we can see here on the signed side, we have jump if equal, jump if not equal, jump if less than, jump if not greater than or equal, right? Jump if less than or equal, jump if not greater, right? And for the most part, if you look at the instruction, you should be able to figure out exactly what it's doing. Unsigned, a little bit different. Jump if equal, jump if not equal, JB, JBE, JNAE, JNAE. Okay, so What you can look at then with these on top of that is they can help clue you in as to whether you're dealing with the signed or unsigned data or numbers as well. And so if you see JEE or JMB, you know that the comparison's being done on unsigned values. So that can help also, little things like that can also help cluing you in as to how that data is being used in the program. Just like in assembly, because this is assembly that we're looking at, we don't have types. We can't say that, you can't say that, you can't define a char, char A or int B inside of your program. And so oftentimes, in order to determine what is the type of a variable, what is the type of an argument to a function, or what is it returning, you have to figure that out contextually. You either have to know the function already, because maybe it's a standard library function, or you look for little clues like this to say, oh, it's doing something unsigned, so I know it's an unsigned value. All right, so anyways, these are the branch instructions. We also have just jump, right? So just a JMP means that it's going to jump, and that would be the unconditional branch instruction, the unconditional counterpart to these. All of these are jumping based off of a condition. Okay, so we'll take a look at if statements with multiple conditions, as well as a nested if, and then we'll wrap up this video. Okay, as far as the resources, you can see here, back in our course folder, underneath static, I have if statement and if statement 2. So we'll take a look at both of those. Both of those I've provided the binaries. We'll also take a look at this nested if. Okay, so the first one up is if statement. So I'll get that loading. Okay, so very simple program, and you can see here that IDA put me right into the main method of that. Let me just adjust these a little bit more. Don't need quite that much room. There we go. Okay, two local variables, int A equals 0, int B equals 5. And if we look at that inside of IDA, we can see EBP plus var 4, EBP plus var 8, right? Two locations that are being referenced relative to our base pointer. So we know that these are in fact local variables. A is equal to 0, so we could just go ahead and rename those real quick. And I'll do that just so that'll help correlate what we're looking at here in IDA with what we're looking to the right with the source code. Okay, so there's A and B. I'm going to zoom this in a little bit too. And here we go. So I'll just try to make that font a little bit bigger. There we go. That should help. Okay, so there's A and there's B. Okay, we rename those based off of their use. They're being initialized with their values, 0 and 5 respectively. Okay, the next thing that we have in main is our if statement. Right? So if A is greater than B, we go down the true branch, otherwise we go down the else branch. So we only say or print A is greater than B if this is true. A is greater than B. Of course, that's the condition that we're looking for. So we can see, big picture in IDA here, is that we have these branches. One goes to the left, one goes to the right. After both of these, regardless of which one we go to, it funnels back to this last code block, which this is XORing EAX. That's moving 0 into EAX, and then it's returning, right? And our main methods return 0 if you don't tell it to return something different. Okay, so in order to get ready for that if, what you'll very commonly see is a compare and then that conditional jump. Okay, so here we can see a comparison, V left and V right, or operand 1, operand 2, and then a conditional comparison, a conditional jump. So jump if less than or equal. This is where things can get a little bit tricky because it doesn't always come through as straightforward as you might expect. If we look at this condition, okay, first thing we have the comparison. So we want to compare EAX to EBP plus B. So we want to compare A and B, of course. That's what we're doing here in this original if statement. So in order to do that, we have to move A into EAX. So now we're ready to compare EAX with EBP plus B. Sometimes you have to backtrace a little bit. Sometimes you have to figure out, if you started this comparison and you see we're comparing EAX to EBP plus B, well, in order to know what that's doing, you have to know what's in EAX. And this highlighting that IDA does within the database is very helpful. And that if you select EAX, select move, you select just about anything, it's going to highlight all the instances of it. And so you can select EAX here, and it'll show you the last time that something was moved into EAX. Now in this case, it's pretty straightforward because it's a very, very small program. So we can see that right before that there was a move, and into EAX we moved the value of A. Now we're using EAX in a comparison. So we might have to backtrace a little bit. You might have to backtrace a little bit in order to figure out exactly how this register, or what data is in this register to do this comparison. Okay, now we're comparing. So we're essentially comparing A to B. And we have inside of this original program, A is greater than B. But what is the comparison, the conditional jump? Less than or equal. It's the exact opposite. What does it do if it's less than or equal? Well, we jump to this location, 40102B. That's this location right here. And we can see that what that's going to do is that's going to push A is not greater than B onto the stack and then call puts, okay, which is A is not greater than B. So now we know this is our else branch. So what this comparison is looking for is to determine to go down the else branch, right? It's the exact opposite condition, because if this were the exact same condition, then what we would be looking for is A is greater than B. But that's not the case here, right? If this is true, jump is less than or equal, we jump to the else branch. We print A is not greater than B. Okay, if we don't take the jump, then we just continue. Right? That's essentially like entering the true branch, that if branch, right? A is greater than B, which is this right here. A is greater than B. So we push the offset for that string on, we call puts, and then we're done. Now, after each branch, whether we go down the if or the else, we end up here, which is the return from main. Okay, it's important to understand, and here we can actually flip to the text view, which gives us that linear representation of the code, and one that I don't spend a ton of time in. But if we scroll down a little bit, here we can see, here's the comparison and here's the jump. Okay, there's those two instructions that we were looking at. If we take the jump, we go to 40102B, okay, which is this location right here. We jump over this code. We need to. We don't want to execute that code because we want to go down what amounts to the else branch right here. If we didn't take that jump, then we would just continue to execute instructions, right? And what do? Well, now we're pushing A is greater than, we're calling puts, we're adding, and now we're doing an unconditional jump. That jump takes us to here, which is that XOR EAX, EAX, move into ESP. This is the end of main function, right? And that's why you see from this code, you see a jump if less than or equal to, right? Because if A is less than or equal to B, we want to go down the else branch. We want to jump over this code, execute this code, and then we're at the end of the function. If it's greater than B, we don't want to jump. We execute this code, and then we unconditionally jump over this to land right here. Okay, so it can take a little bit of time, and I would encourage you, I know probably the first time I go explain or walk through this, it's probably a little bit confusing, and so definitely open up these programs, open up that original C, go through these, and try to understand exactly what's going on. And if you have trouble, let me know so that we can go through some more examples together. All right, spacebar. So spacebar is what allows us to toggle back and forth between those two views. Okay, the next one is an if statement that not only has an additional logical operator, so the logical and, but then it's also an else if. All right, so we have an if with two conditions that we have to check. Then we have an else if. Then we have an else. So let's get that opened up and take a look at that program. Okay, that's if statement 2. All right, so here we go. As you can see, this one's going to be a little bit more, it's going to look a little bit more complex. And I can use the graph view, we can kind of scroll around a little bit. I'm going to go ahead and just close these windows to give me a little more space here. So it's going to look a little bit more complex, even though it's still a very simple, very straightforward program. As far as the main, right, you can go through and rename all these variables. I'm not going to do that just for the sake of time here, but you could rename all of those. Important thing to look at or be able to trace through is the flow. So we have this compare EAX to var 8, and then we have a jump if less than or equal. Okay, well, the first thing that we're doing inside of this original source is we're saying if A is greater than B and A is less than C, right? That's the condition. That's what we're going to print. It's greater than B and less than C. Well, the comparison that we're doing, this is the first thing that we're comparing. And hopefully in one of your 150 or 250 classes, you were told that the condition that you expect to be, in the case of a logical AND, to be false, or in the logical OR, to be true, you put that first. And this is why, because we're doing this comparison first. If this fails, we don't have to do the second comparison, which is exactly what's going to happen here. Look, we're saying less than or equal to. The original condition was greater than or equal. So if that is not true, we don't need to do the second comparison. So we jump to this location, 40103A. Where is that? That's right here. Right? This is that location. What is this doing? It's doing a compare EDX. Well, I'll actually rename these because I think that will help. So this is A. This is B. And that is C. All right, so here we can see we're comparing A and C. I'm sorry. Here you can see we're comparing A and B. Right, A and B. All right, so if that's not true, we jump to this location. What are we doing here? Well, we're moving A into EDX, and C is being compared with the EDX. Right, so we're comparing A and C. Right, well, what we're doing, because we essentially jumped to this else if. We're not comparing that second condition. We're on a completely different else if. So we're saying less than or equal to. Right? The comparison here is greater than C. So again, we're doing the opposite. If that is true, we make the jump. And what does this jump do? A is less than C is what it prints. Okay, that's the else branch. If that's not true, we don't jump. We don't jump, that means we enter into this else if branch and we print A is greater than C. Okay, once we're done, all of these jump back to the end of the function. All right, now we can go back to the beginning and we can take a look at, well, what happens if we don't jump here? So we compare A to B. Well, if A is greater than B, we don't jump because we're comparing it less than or equal to. We go here. Now we're moving A into ECX, and we're comparing ECX, or A, with C, but it's greater than or equal, right? And here we were comparing A as less than C, so we're comparing the opposite condition. If we don't take the jump, we go down this branch, we print A is greater than B and less than C, and then we eventually go to the end of the function. If this is true, if it is greater than or equal, okay, so the opposite condition of A is less than C, then we jump back to here, okay, which means we're now back to this else if branch, where we compare A is greater than or C, A is greater than C, if A is greater than C. Okay, and then that just repeats over. We do the comparison again, whether or not A is greater than C, we either enter into the else branch, the else if branch, or the else branch. Okay, so that's really important to understand that a lot of these comparisons, right? One, we can identify if statements that have multiple comparisons. In this case, if we go from here to jumping to a comparison, or we go from here and we don't jump, but we immediately go to another comparison, right? This flow right here is showing us that we're making multiple comparisons in that one if statement. This jump to another compare is showing us that we're actually jumping to an else if. Okay, and so again, it can be a little bit confusing because you're kind of looking at these backwards because you're getting instructions that don't match up exactly with what we originally had. We're kind of doing the opposite flow. But if you took the time and you put this into the text view, you'd see some of the reasons why we do the jump. Because if we don't jump, we go to that next instruction, go to that next compare. If we didn't take this jump, then the next instruction would be this move ECX, compare ECX, and then jump if greater than or equal, right? Because of the linear flow, everything's an address. Okay. Last thing that we'll look at here today is the nested if. And you can see again a relatively straightforward program that we have an if with an else, and then inside of that we have if with an else, and then just puts. And I put those in there just to help being able to a little bit more easily identify what branch that we're going down. All right, give it a second here. We'll have our graph view, close that as well. Okay, just like the last one, it starts to look more complex because now we're seeing with all these additional comparisons that need to be made, different branches of execution, different jumps, conditional and unconditional, as well as the different blocks of code that represent those locations and those instructions that are there. Here you can see, and let's go ahead and I'll label these as well. So x is 0, y is 1. Whoops, what did I do? There we go. And this last one is z. Okay, so 0, 1, 0. We can see that all this does here is prints off a string, enter a number, and then it does a scanf call. So here you can see those calls, puts, and scanf. Once it's done though, there's the comparison. So if x is less than 10, there's the condition right there. Compare EBP plus x to 10. So this is hard coded, so we don't have to move a value into a register to compare to a register. This is an immediate value, so we can see that comparison right away. Less than 10, well, we have a jump if greater than or equal. So if it's less than 10, we don't jump. We go right here. Where are we at now? Well, we're inside of this if. And what is the first thing that we do inside of this if? It's another comparison. We're comparing if z is greater than 0. So you can see that. If z and 0. Okay, jump if less than or equal. So if it's less than or equal 0, then we make the jump. And you can see we're printing x is less than 10 and z is less than or equal to 0, which is this string in this print right here. Okay, if we don't take the jump, x is less than 10 and z is greater than 0, right, which is this right here. Okay, once those are done, you can see now we're just jumping to, both of those will funnel to this jump, and that jump takes us to the end of our function. 401085 is essentially the epilogue for that program. Okay, go back to that original compare. X is 10. Okay, if it is greater than or equal, then we make the jump to here, right, which is taking us to the else branch. Now with the else branch, we're going to have pretty much the same thing. If z is greater than 0, x is greater than or equal to 10, right, so the print statements are different. But because in this else branch, the first thing we do is a comparison, that's what we're doing here. Right, so if we don't take the jump, then we go into the if branch. So greater than or equal to 10, and z is greater than 0, which you can see matches up right here. So again, just using those prints to help positively identify where we're at based off of that original source. If we do take the jump, we go to this location. And here you can see greater than or equal to 10, z is less than 0. X is greater than or equal to 10, z is less than 0. Okay, so that just shows us where we're at. Again, all these branches ultimately end back down here, which is our return from main. Okay, so even though this is more, it looks a little bit more confusing and it takes a little bit more time to trace through the logic, that's what you're going to have to be able to do, is to look at the different comparisons that are being done, the data that's being compared, and then the type of conditional jump that is being performed. And that tells us that we have branching logic, that this logic is it's going to go to the left or to the right. It's going to make this jump or it's not, based off of that comparison. So the program, the execution flow of the program will be different based off of this comparison and this jump. Right? Here's an example, a good example of an unconditional jump. Right? Regardless of what happens here, we're either going to do the if or the else, because that's how if statements work. We either do this, it's either true or it's not. Regardless, when we're done, we need to jump over this else branch. So we have a jump to this location, which is the end of our main program, or the end of our main function. Okay, so trace through that flow. And again, if something's not quite making sense or clicking, or you're not understanding how I'm going and essentially translating this original source into this type of a program, let me know so that I can provide more examples or work with you one-on-one. All right, so that's all for this video. That's if statements, nested if statements with some that have logical conditions or compound conditions. In the next video, we'll look at loops and switch tables.